Hi, good evening. In the last lecture, we discussed about convolutional encoding using transform domain approach, and in this lecture, we are going to discuss about convolutional encoding using graphical approach. Okay, so graphical approach. So in graphical approach, mainly we are having three things. One is code tree, and second one trellis structure, and third one state diagram. So using any one of these, we can encode the given sequence using graphical approach. Okay, so but before going into the graphical approach using any one of these techniques, so let us consider our previous example, the rate to 1/2 encoder. So rate 1/2, constraint length capital K equal to 3 encoder, so which is okay, and these are the two outputs, first one, second one, first output, second output, and a multiplexer. This is the input. Okay, and you can clearly see we are having two memory elements. So the encoder can have a maximum of 4 states because we are having two memory elements. So states can be either 0 0 0 1 or 1 0 or 1 1. So there may be 4 possible states. So let us denote the initial state as 0 0, which is, let us denote with A. Okay, right. So before going into any one of the approaches, either code tree or trellis structure or state diagram, so we need to form a table. It is better to form a table. Okay, so this table helps us in correctly drawing the code tree or trellis structure or the state diagram. So what does this table consist of? Okay, so this table will be having 4 entries. The 4 entries may be input, present state, next state, and output. So the encoder will be having any one of the states. Let us start with initial state as 0 0. Okay, so when the encoder in state 0 0, that is A, input may be either 0 or 1. So let us just take input as 0. Now output, how to compute the output? So the first output is sum of modulo 2 addition of the input, the first memory element content, and second memory element content. So modulo 2 addition of all these 3 bits. And coming to second output, input bit and the content of the second memory element. So input and content of second memory element, that means the first bit, the input bit, and this second bit in the present state. So 0 0. And what is the next state? Next state means for every clock pulse, the input bit will be shifted into the first memory element, the content of the first memory element will be shifted to the second memory element. So shift will be in this way. So this bit will be shifted to this bit, this will be shifted to this bit. So in that sense, the next state will be 0 0. Okay, suppose if the initial state is 0 0, if the input bit is 1, then the output, the first output will be 1, similarly second output is also 1. Next state, so this will shift here, this will shift here, so 1 0. So when we are in state A, there are 2 input bit possibilities. One is bit 0, one is bit 1. So when the state is in 0 0, if the input bit is 0, we move to the same state, that is A. And when we are in state A, if the input bit is 1, and we move to a new state which is 1 0, let us call this as B. So 1 0 state is called as B. Now consider state B now, which is 1 0. Again the input may be either 0 or 1. If the input bit is 0, then the output will be 1. Second output is 0. Next state will be 0 1. If the input if the state is 1 0, if the input bit is 1, then next the output will be, the first output will be 1 plus 1 0. Second output is 1 plus 0, this 1, and next state it will be 1 1. Right. So when the encoder in state B, if the input bit is 0, it is moving to state 0 1. If the encoder in state B, if the input bit is 1, it is moving to state 1 1. So call this as C and D. And now consider C, which is 0 1. Input bit is 0. Now the output 1 1. Next state 0 0, which is A. Similarly, input bit 1, output is 0 0. Next state is 1 0, which is B. So when you are in state C, if the input is 0, the next state is 0 0 A. If the input is 1, the next state is 1 0, which is B. These are the corresponding outputs. Now consider last state, which is D 1 1. If the input bit is 0, the output is 0 plus 1 plus 1 0, 0 plus 1 1. Next state is 0 1, which is C. Next, if the input bit is 1, then the first output is 1, second output is 0. Next state will be 1, which is D. Okay. So when we are in state A, depending upon the input bit, we are moving to either state A or state B with these outputs. When we are in state B, we are moving to state C and state D with these outputs. In state C, we are moving to state A and state B with these outputs. When we are in state D, input bit is 0, we are moving to state C. If the input bit is 1, we are moving to state D. Okay. So having this table is with this table we can go ahead with either code tree or trellis structure or state diagram. Okay. So for any given encoder, so first of all please form this table, and 0 1 is state C, 1 1 is state D. Okay. So I have this state table. So with this state table we can go ahead with any one of the structures. So let us start the code tree. Okay. So before drawing code tree, let us note down a few points. First point, so every branch represents an input bit. That is, every branch of the code tree represents an input bit that may be either 0 or 1. Second point, the upper branch of the bifurcation is nothing but division of a branch. So the upper branch of the bifurcation denotes a bit 0. Similarly, the lower branch of the bifurcation denotes bit 1. Okay. For example, let us say this is a branch. So upper branch corresponds to a bit 0, so upper branch, and lower branch, that is lower branch, corresponds to a bit 1. So that is what we said. So this is the bifurcation point. So at the bifurcation, if the path is moving upwards, it represents input bit of 0. If the path is moving downwards, it represents the input bit of 1. Okay. Next, fourth point. Right. So if you want to encode a sequence, so you have to trace the path on the code tree from left to right. Okay. So the encoded sequence path has to be traced from left to right. Okay, so after forming the code tree, if you want to encode the given message sequence, we have to trace the path from left to right. Okay, so these points have to be remembered while drawing a code tree. Okay, so now let us draw the code tree for the encoder which we discussed earlier. Okay, so we discussed that the initial state is always 0 0. Okay, so I will start with the initial state as 0 0, which is A. So now, okay, so we are moving in upper branch. So from the table, if you are in state A and we are moving upwards, so the upper branch of the bifurcation indicates a bit 0. So when we are in state A, if the input is 0, then the next state is A, and the corresponding output we need to indicate on the branch. Okay, so if you look at the table clearly, okay, so look at this table. So if you look at this table, when we are in state A, okay, so when we are in state A, that is 0 0 state. If the input bit is 0, then the output is 0 0. So if you are in state A, if the input bit is 1, output is 1 1. Okay, so we need to indicate these outputs on the branch. Okay, so I will indicate that on the branch, right? So 0 0. Now again, this is one branch indicating a bit 0. So again at this point, the branch bifurcation. So now, so when we are in state A, the upper branch indicates bit 0. So when we are in state A, we move to state A only, and output is 0 0. When we are in state A, lower branch indicates a bit 0, we move to state B, output is 1 1. Okay, similarly we need to divide these two again. So when we are in state A again, okay, so when we are in state A, if 0 comes, next state is A, if 1 comes, next state is B, output is 0 0 1 1. Again we need to bifurcate this. So when we are in state A, okay, if the input is 0, the next state is A. If the input is 1, next state is B. Again, so one more bifurcation. So if the input is 0, we'll move to state A. If the input is 1, we'll move to state B. This is 0 0 1 1. Here also 0 0 1 1. Now come to this. If we are in state B, if the input is 0, we'll move to state C. If the input is 1, we'll move to state D. The corresponding outputs are 1 0 and 0 1. Okay, now come to here B. When you are in state B, if the input is 0, we'll move to state C. If the input is 1, we'll move to state D with the outputs of 1 0 and 0 1. Now when we are in state C, if the input is 0, we'll move to A. If the input is 1, we'll move to B. Outputs are 1 1 and 0 0. When the state is D, when the input is 0, we'll move to state C. When the input is 1, we'll move to state D itself. So outputs are 0 1 and 1 0. Okay, so similarly we need to draw at this point also. Okay, now when we are in state B, we move to state C and state D. with 1 0 and 0 1 as the outputs. When we are in state C, we move to state A and state B with outputs 1 1 and 0 0. When we are in state A, we move to state A and state B 1 1 and 0 0 and 1 1. When we are in state B, we move to state C and state D with outputs 1 0 and 0 1. Now coming to D. When we are in D, we move to state C and D with outputs 0 1 1 0. When we are in state C, we move to state A and state B with outputs 1 1 0 0. When we are in state D, we move to state C and state D. So outputs are 0 1 1 0. Okay. So if you see this, we constructed only one top branch, and in a similar manner, see, from the initial state A, we move in the upper direction, and similarly we have to move in the lower direction also. Okay, so let us complete that diagram. Okay, so when you are in initial state A, when 1 comes, so when 1 comes, the state is B, output is 1 1. Now when you are in B, so when 0 comes, we'll move to C. When 1 comes, we'll move to D with outputs of 1 0 and 0 1. Now when you are in C, we move to A and B with outputs of 1 1 and 0 0. When you are in A, we move to A and B, which is 0 0 1 1. When we are in A, we move to A, we move to B, which is 0 0 1 1. When we are in B, we move to C and D, which is 1 0 0 1. When we are in B, we move to C and D, which is 1 0 0 1. When we are in C, we move to A, we move to B, which is 1 1 and 0 0. When we are in D, we move to C and D, which is 0 1 1 0. Okay, in a similar manner, let us complete this one also. Yeah, when we are in D, so when we are in D, we may be in C and D, which is 0 1 1 0. When we are in C, we will be in A and B, which is 1 1 0 0. When we are in A, it will be A and B, which is 0 0 1 1. When we are in B, we will be moving to C and D, which is 1 0 0 1. And similarly, when we are in D, we will move to C as well as D, which is 0 1 1 0. When we are in C, we will move to A and B, which is 1 1 0 0. When we are in D, we will move to C and D, which is 0 1 and 1 0. Okay, so this completes your structure. Okay, so the entire structure of the code tree. Okay, so now I will simply minimize this. Right, so this is the code tree what we have built. Okay, so if you see this clearly, this is the first bifurcation at when the initial state is A, when 0 comes upper branch, when 1 comes lower branch. Again, when we are in A, 0 comes, 1 comes, upper branch, lower branch. Again, when you are in A, again 0 and 1. So we have drawn this code tree up to 5 stages. First one, first bifurcation, second, third, fourth and fifth bifurcation. And if you notice clearly, after 3 bifurcations, that means first one, second one and third one, okay, if you notice the structure A B C D, A B C D, okay, and A B C D, A B C D, A B C D, A B C D. So after 3 branches the structure is repeating, okay. So what we can do with this point, okay, I'll explain you later. So but before that, let us encode the given sequence. So let us consider our message sequence as 1 0 0 1 1, the previous example what we discussed, okay. So how to encode the given message sequence using the code tree structure, okay. So now as discussed, in order to encode the given message sequence we have to trace the path from left to right, okay. So the first bit is 1. So at the first bifurcation point we have to move downwards, so let us move downwards, okay. So what is the output on this path? The output is 1 1. So bit 1 is encoded as 1 1. Next, the second bit is 0. So at this bifurcation point, that means at state B, so because the bit is 0 we have to take upper branch. So let me take the upper branch, we will arrive at here. So because the input is 0 we have taken the upper path, upper branch, and what is the corresponding output here? 1 0. So 1 0. So let me zoom this a little bit. Hold on. Yeah. So a message sequence is 1 0 0 1 1. So for the first bit, so we have taken the lower branch. We have taken the lower branch. The corresponding output is 1 1. Next bit is 0. We have taken the upper branch, so output is 1 0. Okay. So now, yeah. So for the first bit the output is 1 1. Second bit output is 1 0. Now third bit is 0. So third bit is 0 means from this bifurcation point we have to move again upward. So if I move upward, so I will be at this state. So what is the output now on the branch? 1 1. Next bit is 1. So we have to move downwards from this bifurcation point. So I will move downwards. So what is the output on this path? 1 1. Next, at this bifurcation point the next bit is 1. Again we have to move downwards. So if I move downwards, what is the output? 0 1. Okay. So this is your encoded message sequence. Okay. So for in order to encode the given message sequence we have to trace the path from left to right. So first bit is 0, we have moved downwards, which is 1 1. Next bit is 0, we moved upwards, output is 1 0. Next bit is also 0, we moved upwards, output is 1 1. Next bit is 1, we moved downwards, output is 1 1. Next bit is 1, we moved downwards, output is 0 1. Okay. So in this way we have to encode the given message sequence. So this is the output sequence. So 1 1 1 0 1 1 1 1 and 0 1. Okay. So in this way you can encode any given message sequence using the code tree. But remember that, so the message sequence length is 5. So that is the reason why I have drawn 5 branches of the code tree. So if the message sequence is more than 5, okay, so you need not draw the rest of the branches, because if you look at the figure carefully, after 3 branches the structure repeats. Okay. So you can use that point, right? So now if you clearly see this, after 3 branches the structure is repeating. Okay. So in what way we can make use of this? Suppose if the input message sequence is 1 comma 0 comma 0 some m3 comma m4 and so on. So m0, m1, m2, m3. Similarly, if the message sequence is 0 comma 0 comma 0, m3, m4 and so on. So if the message sequence is like this, 1 0 0 m3 m4, 1 means we will be coming downwards, 0 0 at this point. Similarly, all zeros, that means we will be moving 0 0 and 0. So if the first, look at this carefully. So whether the input sequence starts with 100 or 000. So after 3 branches, the structure is same. That means encoding m3 m4 is same, m3 m4 in this message sequence also same. So what we can do is we can re-merge these repetitive structure. Okay, so after 3 branches the structure is repeating, so we can reduce this structure by re-merging the branches after 3 stages. So if you come in this structure, so at this point we got A, at this point also we got A, so we can re-merge these 2 states. Similarly, if you go with 0 0 1 or 1 0 1, so again we are getting B, so we can re-merge those 2 branches. Okay, so as the structure is repeating after 3 branches, we can re-merge those states and we can obtain a new structure, and that new structure with re-merging branches is called as trellis structure. Okay, so trellis structure is simplified form of the code tree with re-merging branches. So it has been given the name because it is having re-merging branches. A tree with re-merging branches is called as a trellis. Okay, so next we will look at how to draw the trellis structure for the given encoder, and using the trellis structure we can encode the given message sequence. Okay,